BBC4 Collections, specially chosen programmes from the BBC archive.
"25 years ago, Panorama was broadcast for the first time. Tonight, to mark our Silver Jubilee, we're bringing you a special programme in two parts. The second part will follow the 9 o'clock news. It's called The Real War in Space. In 1953, the space race hadn't even started. That year, Everest was climbed for the first time, but the highest flight by man was still only about twice as high.
Tell me when to go. As Secretary General of the Royal Aero Club, I have great pleasure in announcing, subject to confirmation of the Fédération Aéronautique Internationale, that the height attained in this attempt upon the world aeroplane height record is 63,668 feet.
Well, may I congratulate you, Wing Commander Gibb. Did you wear anything special?
I wore all the latest safety equipment.
And underneath?
Pants and vests, normal clothing.
The 25 years since have made nonsense of records like that. Missions to the moon and orbiting laboratories have led us to expect new adventures out into space. In this anniversary programme, we decided to concentrate on that future rather than the past. With his report, The Real War in Space, here's Tom Mangold.
Last week, at a two-day meeting of NATO's nuclear planning group in Brussels, our Defence Minister, Fred Mulley, together with 6 other ministers, received a top-secret briefing from American intelligence on the subject of directed energy weapons. These are new and devastating space rays that have already begun to revolutionize military strategy and behavior in space. This closely guarded subject was opened up to the NATO defence ministers because of the growing concern about Soviet developments in this field. Mr. Mulley told Panorama this afternoon, much work is being done in both the United States and the Soviet Union on directed energy weapons, work which we in NATO must watch closely. And today we've also heard that the American Air Force is about to establish a new space command. The fear is that the development of these frightening new weapons is giving man the potential to militarize space even further. This is a move that could easily upset the delicate balance of terror which has helped keep the peace for the last 3 decades. The current round of strategic arms limitation talks has no bearings on this space arms race. So tonight we look ahead at the growing dangers of a real war in space. In part 1 we shall deal with today's threats in space, and after the news we'll be back to look at the new and exotic space weapon technologies. War in space then, a possibility that has always had a compulsive fascination.
Ships coming up fast behind us.
Buddy, break the controls. The portholes are giving way, Buck. It's no use. The heat has melted the valve heads. Move, buddy.
There's only one hope for us. Climb above this atmosphere back into outer space.
Buck Rogers waging war in space for the youngsters of the 30s. But today that science fiction dream to invade, occupy and hold the ultimate high ground is turning into deadly reality. Earth, where armies once clashed on foot, has become the launch pad from which the new machines will fly to fight alone in the silence and vacuum of space. Satellites, for 20 years invulnerable in their celestial isolation, could now be destroyed by high-energy laser beams mounted on killer satellites attacking at the speed of light.
war of the future will probably not be a war in which nuclear bombs explode everywhere and our cities are all leveled. It will be a war of wills, a contest of minds in which the two great superpowers will try to persuade the other that he has the capability to achieve a total domination of some economic resource or some political region which is important to him, and that the other side dare not interfere. Now, in view of the character of our two societies, it's easy to see that the hunter-killer satellite, which could threaten to blind us when we needed to react wisely but cautiously without resort to total war, plays into the hands of the Soviet Union.
The Soviet strategic writings make it crystal clear that an initial period of a global nuclear exchange would be disastrous unless it was controlled. And the Soviets intend to control that initial period, and the most important task for them is to deny us our eyes and ears in space, and that's what satellite killers and lasers in space are all about.
By coincidence, the laser was born in the same year as the Sputnik, the world's first spacecraft. Both have come a long way since then. Fundamentally, the high-energy laser is a highly concentrated and focused beam of light, converted into energy, that can then be propelled against any object. When that laser beam hits its target, it destroys what it touches by burning, and that goes for anything from paper to steel to granite. Lasers are already used in medicine and industrial cutting. But the United States has now spent $1 billion on detailed research and testing of high-energy lasers as space war weapons.
5, 4, 3, 2, 1, fire!
They could now be ready for use in space within 3 years.
The advantage of space for lasers is you don't have to worry about the atmosphere. It's just that simple. The atmosphere tends to defocus and presents problems if you have very intense lasers on the surface of the Earth. The question is just what will be the applications of lasers in space? And that's the question. For defense purposes, there are some, let me call them Buck Rogers applications. On the other hand, if 20 years ago you were to say we would have walked on the moon already, people would have thought that was pretty ridiculous.
Nothing now remains ridiculous in contemplating the real war in space. Weapons that would have earned the derision of Buck Rogers himself are today being researched and tested in laboratories in Russia and America. If the high-energy laser can be compared to focusing the rays of the sun through a giant magnifying glass, the devastating new particle beam weapon can be compared to harnessing and controlling bolts of lightning. These weapons are already in an advanced state of research. They would work by converting colossal amounts of energy into subatomic particles. These are then shot through the atmosphere and space in the form of a beam, and they're shot with such force and at such speed that the beam effectively disembowels its target. By destroying all known matter, the particle beam is today's ultimate space weapon. One of the nuclear scientists who's been doing military research on particle beam weapons shows what happened after only 5 seconds in a simple little laboratory experiment when the beam was turned onto solid granite.
Well, I have here a rock which we sometime in the past irradiated with an electron beam. As you can see, we melted a hole with this electron beam right through this rock. This was relatively low power. It was, of course, done in a laboratory, but a charged particle beam can certainly melt and destroy most anything it strikes.
And it just burned its way straight through, what, 2.5, 3 inches of rock?
Yes.
Just like that. What's that black stuff there?
The black is the fused rock. It's like an obsidian or a glass, which is made after the rock has been melted and then refused together.
Now, if that was done with a low power beam, what would a high power beam do?
Well, it might be able to do this much faster, for example, or it might be able to do it over a much larger area.
And cause considerably more damage than that.
Oh, of course.
But why, after 3 decades of peace on Earth, should there even be the prospect of war in space? In the last 10 years, there's been an unpublicized military revolution.
In the 1960s, American technological know-how and genius simply turned to space in a massive way to perform support functions, not offensive functions, that could be accomplished far more efficiently than they could on the Earth plane. And what the United States has done is to put several hundred satellites in space that accomplish most of our early warning detection of a Soviet attack. We have put much of our communications intercept capability, our ability to intercept exotic new Soviet radars in space. 100% of our ability to predict weather is now in space. Soon, most of our ability to navigate submarines and ships and aircraft precisely at sea and over land will be based in space. When you add all of these up, plus the fact that virtually all of our reliable, strategic, long-haul communications are now in space, our ability to control strategic forces, and very soon, most of our ability to command forces in defense of NATO and other threatened areas of the world will be in space.
Photo reconnaissance satellites have become an important stabilizing factor in world affairs, in the monitoring of arms control agreements. They make an immense contribution to the security of all nations. We shall continue to develop them.
Behind the President's first ever public admission of the existence of spy satellites rests an even grimmer truth. Their activities make it almost impossible for one superpower to prepare for war in secret, so they keep international peace of mind and peace. Without them, superpower fear and Cold War suspicion would return overnight. Spy satellites are launched regularly by both sides, either to hover high over selected military areas or to swoop in low orbit to take special pictures. Giant steel dishes, some of them placed here in Britain, eavesdrop day and night on the electronic babblings from space. Once enhanced by computers, spy satellite pictures can show a calm number plate on the ground from over 200 miles in space. This is an electronically coded signal from a camera in space actually being received at a ground station near Washington, D.C. The signal will be converted into film. This spying without tears continues day and night by satellites who hang around in space minding everyone else's military business. Unless it's a cloudy day or you move everything underground, there's nothing you can do about it. Once the film has been processed, you can be sure someone somewhere is keeping an eye on your most secret endeavors. Although the precise accuracy of spy satellite pictures is secret, these shots give an indication of what the satellites can see. Here it's streets and bridges. But more significantly, this satellite picture shows visible details of the secret Soviet rocket launch site at Kapustin Yar, 600 miles southeast of Moscow. It's now impossible for either side to build and maintain a site like this without most details being snapped from space.
50% of our secret information now comes from the interpretation of the data on satellite films.
Dr. Klein, what about the value of communications satellites to intelligence agencies all over the world?
An agent in the field, if he's valuable and in place, can use an instantaneous release transmitter which will be aimed at a satellite and will be received virtually instantaneously in Washington, D.C. or wherever an intelligence headquarters is. This changes the timing and the relevancy of the kind of information which supplements satellite reconnaissance.
And will there ever be any question of going back or dropping that particular area of dependence?
You can't reinvent the horse and buggy because the facilities for creating those earlier modes of activity tend to die out when new technology comes along.
Some of that technology is being used here in California. At this factory, TRW, they make military satellites for all the armed services. Recently, a key TRW employee, Christopher Boyce, sold satellite secrets to the Russians. He was caught and sent to prison, and today security is a priority at the whole complex. Each separate section of the building needs special clearance before entry. Once inside, the atmosphere is like a British munitions factory during the war. TRW builds a satellite called Discus, a military communications satellite containing 1,300 secret and unjammable channels for telephone and telex.
Oh, is this the transmitter that came off Flight 9? It's been back though.
Yorkshire-born Alan Parker is in charge of the highly classified Discus Satellites project. When they're launched, they will girdle the globe on behalf of the United States Armed Services.
With the Discus type of satellite, we are capable of talking directly from Washington to a commander in the field. And so the communication time is very significantly reduced and is direct communication. Or it has the capability through its ground station of handling coded information, scrambled information, such that no other agency or no other country could access this information. Whenever the president makes a visit abroad, such as to the Middle East or the Far East, or even to Moscow, these satellites are repositioned if necessary, such that the president can stay in touch with Washington at all times, and hence with the rest of the military or the government agencies throughout the rest of the world.
And he uses it in his role as Commander-in-Chief?
That's correct.
Does that mean that those little telephones that always go with him, which are carried by the Secret Service, are linked somehow into the satellite system?
That's right. Through a ground station into the satellite and back into a ground station and back to the Washington system.
Another satellite, Navstar Global Positioning System, or GPS, will tell anyone who dials in exactly where he is anywhere in the world.
That soldier is, has a piece of manpack equipment, part of the Global Positioning System user equipment. And he currently is getting a position fix by receiving signals from satellites that are moving overhead. The satellites are radiating signals continuously, and so he is receiving those signals, and that's a passive unit.
And just how accurate is that set?
That set will provide position accuracy anywhere on the globe within 10 meters or less.
GPS will give warships an instantaneous day and night fix in 3 dimensions, making star navigation as obsolete as the bow and arrow. The Army and Navy are, of course, delighted, but it's the U.S. Air Force that will gain most.
Navstar, in the area of precise weapons delivery, represents what I would call a quantum jump, almost a factor of 10 improvement in our capability to accurately deliver weapons. Blind bombing, coordinate bombing. You know the coordinates of a target, you want to hit that target. One of the things you want to be able to do in attacking that target is to come in quiet, number one, without radiating energy. GPS will allow you to do that. You want to be able to, one of the prime problems we have in attacking a target is finding out where the target is. Then, once we find it, we have to acquire it, target acquisition, and attack it. GPS allows all of that to be done automatically. The pilot, in essence, can plug in the target into his GPS computer, plug in the coordinates of that target, and virtually fly a needle automatically, and the bomb will be released automatically to hit that target. Someone has speculated that GPS would eventually be used on anything that floats, flies, runs, walks, crawls, or slithers, and I'm not so sure about the latter.
In the desert of New Mexico, the United States Air Force has just begun a new space watch. A computer-controlled camera spies on deepest space and shadows a satellite that is itself spying on the Earth.
Okay, what's the next object that you want to track?
Next object would be 9635, a modeling of payload.
Okay, let's go ahead and put that in. Let's see if we get move this this around a little bit. I don't see anything here. It looks like we're in the maybe half degree. Maybe we ought to switch to, you see it yet? I don't. Let's see, maybe, let's move this around a little bit, move the telescope some. Still don't see the object just yet. Okay.
Move another field. There he is.
There he is. Okay.
Now we're ready to go to the next field.
Yeah. Let's take a little bit of data on him and see where we're going.
We have data at 21, 49, 39.
All right, fine. It'll take a few minutes here. Keep track of him. Okay.
What do you do with all this information? You pass it on to where?
Well, we are part of the Aerospace Defense Command. This data is sent via teletype back to the Cheyenne Mountain complex in Colorado Springs, Colorado. They use
That's NORAD?
Yes, yes. They also use this data to, along with data that's provided by other sensors, to predict where these satellites will be at any time in the future. And of course, their job is the maintenance of the location and identification of all the satellites in space.
Now, why do you need to track Soviet satellites at all?
Well, not just Soviet satellites, but all satellites that are put into orbit. We want to maintain surveillance of all these satellites to continually know where they are, and also to determine if a new satellite is up there.
Why is that information required?
Well, you got me.
Satellite information from space is flashed first to a mountain in Colorado, headquarters of the whole North American air defense system, and one of the few top security defense complexes built to survive a nuclear war, no matter how destructive. Through the mouths of tunnel in the heart of Cheyenne Mountain lies an underground city. It's built on giant shock absorbers to withstand the blast of a direct nuclear hit. It has its own private reservoir and food supplies. In the event of war, these 25-ton steel doors would swing shut, locking 1,000 pre-selected mission-essential personnel into the mountain's heart. What would happen to the remaining 1,000 mission non-essential servicemen is unclear. Inside is the Space Defense Center, where the Air Force maintains a permanent space track. Every single man-made object in space, and there are currently 5,000, must be tracked and accounted for. Every non-friendly satellite's mission must be monitored and explained. If there were to be hostilities in space, how crucial would this center be?
This center is very crucial because we provide positional information on satellites. Now, the Soviet satellites naturally don't tell us where they are, so we use our data to predict where they, to determine where they are, where they're going to be. Certainly, when you tie in the positional information with the mission information, then you've got yourself a fairly good picture of what the intelligence people need to determine intentions. Well, with this TV display, we can take a look at any one of 100 satellites which we have in our database. At the present time, we're taking a look at Salyut 6, which is the Soviet space station, which is in orbit. Present time, it's coming up just south of the Aleutian Islands, here in Alaska. Now,
and that line is its predicted course, is it?
That is the predicted ground trace, which it will make as it travels about the Earth, yes.
And do you think the Soviets have got a system like this for keeping an eye on your satellites as well?
I would think that anybody that's going to operate a viable space program or a viable missile warning system has to know where their satellites are and when and where they're going to be at certain locations so that they can discriminate between what is there and what is unknown.
America has some 400 satellites in space, the Russians 466. It was only by some sharp monitoring from this Space Defense Center that it was discovered last year that the Russians were testing hunter-killer satellites, an event that began the arms race in space.
There he is. He's a big one.
The Russian space program is significantly different from the American. 8 out of 10 Soviet launches are military against only 5 out of 10 American launches. Russia, like the West, depends on satellites, and in some vital military areas even more than the West, such as spying on America's huge globally dispersed navy. Soviet astronauts are usually servicemen, like those involved in the recent record-breaking space trips in the Salyut space stations. 2 of this series of spacecraft were huge orbiting military workshops. It's now known that part of the Salyut 5 trip was spent calibrating new and highly sensitive spy cameras. American electronic listening satellites also heard the Russian Salyut astronauts talking in code to ground control.
3 and 5 almost certainly were military space stations. There are many things that help us classify those as military. They flew low enough to take high-resolution pictures. They had all military crews. The telemetry formats were not unlike those of some of the military picture takers.
There's even some unconfirmed evidence that Salyut 5 tested high-energy laser components during its 14 months in space. And it is now certain that Russia has developed the world's first anti-satellite weapon, a hunter-killer satellite. An anti-satellite weapon is known as an ASAT. For years, the Americans closely monitored a series of curious and at first inexplicable Russian satellite launchings. Then the spaceflights seemed to fit no known mission pattern. But soon it became clear that the Soviets had been testing and had now successfully developed in space a hunter-killer satellite. The Cosmos interceptor satellites that have been tested so far work like this. Having identified and been guided to the target satellite, the Cosmos maneuvers up beside it and then explodes. The resulting fragments of shrapnel from the explosion will completely wreck the delicate systems on the target satellite and put it out of action.
Since they have tried many different patterns of approach to their targets, fast passes in an eccentric orbit, a close co-orbit where they can linger near the target, quick pop-ups where they can get up to the target in a matter of minutes rather than hours or days. All of these things suggest that they are trying out a lot of technology.
But how quickly could they launch their hunter-killer satellites, and how effective would they be?
Well, the launch vehicle which is used for the interceptors is based upon the SS-9, which has storable fuel. So providing they themselves decide that it is ready to go operational, it presumably could be launched in a very few minutes.
The Soviet Union, which traditionally has lagged a few years behind us in developing all of these things, keeps searching for quantum jumps in technology which will permit them to negate our generally superior work in these fields. And the hunter-killer satellite is obviously one. It gives them an edge because they could threaten to use it against us in a time of crisis, and without actually using it, make it very difficult for us to respond forcefully and effectively in the less than total war mode in which modern conflicts are usually played out.
Shocked by what it saw as a militarily provocative development, Carter's administration reacted by joining the arms race in space while simultaneously proposing talks to end it. Secretary of Defense Harold Brown put it this way:
we might have to take steps to deter attacks on our satellites, to deal with attacks, and to have the capability to destroy Soviet satellites. It would be preferable for both sides to join in on an effective ban on anti-satellite ASAT systems. We certainly have no desire to engage in a space weapons race. However, the Soviets, with their present capability, are leaving us with little choice. Because of our growing dependence on space systems, we can hardly permit them to have a dominant position in the ASAT realm.
So last June, the Russians and Americans met quietly for the least publicized disarmaments talks in history in Helsinki. What was and remains at stake here in the prosaically named anti-satellite talks is the opportunity to halt the drift towards war in space. The Americans, under Chief Negotiator Ambassador Paul Warnke, seek the dismantling of the new Soviet hunter-killer satellite as part of a deal. Failure in the talks will accelerate the arms race in space and could easily destroy the tacit agreements that have so far ruled superpower space behavior. But these talks were only exploratory.
What we hope to be able to accomplish is a declaration of the fact that interferences with satellites are prohibited acts, and also a further agreement that would prevent the testing, deployment, or retention of an anti-satellite capability.
Now, Ambassador, what's going to happen if these talks simply drag on and on? Isn't it possible that both sides will simply continue to maintain the development of their anti-satellite weapons?
I think that that would be very, very likely. I think if the talks continue over a protracted period of time, that you may find that the subject matter has become moot, because both sides will have developed weapons that are effective satellite killers.
And it will then be a little too late to do anything about it.
It'll be too late to do anything about it, yeah. See, that's always the problem in arms control. I mean, you're always racing against technology. And quite frequently, you don't get the agreement in time, and something has escaped from effective control. That could very well be the case with anti-satellite devices.
But that race against technology is effectively lost before it starts. The arms race in space having begun, it'll be fueled by the new and exotic technologies of the late 70s. The United States has already commissioned a multi-million-dollar program to build this ASAT warhead. It's a complex device. Little rocket propulsion tubes the diameter of mortar bombs that first maneuver the hunter-killer to its target will then be fired like cannon shells. But even that system could soon be old hat, as this censored report to the American Congress keeps trying to say.
This program consists of two parallel engineering development efforts for an Air Force anti-satellite ASAT system. A designed to B, a non-nuclear ASAT vehicle designed to... This system is being developed as a low-risk, off-the-shelf hedge in the event difficulties are encountered in the development of the... In addition, the Air Force will continue to evaluate technology for possible application to the ASAT mission.
In fact, those missing words refer to high-energy lasers, and the United States Air Force is now deeply committed to the full-scale researching and testing of lasers as anti-satellite weapons, much of it done at this base in Albuquerque, New Mexico. We know high-energy lasers have already shot down robot planes. This converted Boeing as a flying laser weapons testbed, solving fundamental problems such as finding the target, pointing the laser at it and holding the beam steady. This tracked vehicle is the Army's laser testbed. It's like a tank, but with a high-energy laser instead of a gun. Testing has now reached an advanced stage. In space, the gun and missile are slow and clumsy compared with the laser's speed of light accuracy. Because there can be no bomb blast in the vacuum of space, the laser, with its guaranteed ability to destroy, operates far more efficiently and is clearly the ideal weapon for war in space. This enormous laser potential was quickly recognized by the director of the American Defense Department's Advanced Research Projects Agency, Dr. George Heilmeyer.
It is my belief that the high-energy laser in space could represent a Sputnik-like event, a technical achievement which could influence the perceptions of foreign countries as to who is leader in defense-related technology.
In 1976, we acquired, through very sensitive clandestine sources of high reliability, information that the Soviets planned in 1977 to test a space-based laser gun of about 10 times more power than any laser in development in the United States. And that the purpose of this laser would be to displace the 2 generations of anti-satellites, which are awkward interceptors because they require such large rockets. But that this would be a revolution in the ability of the Soviets to deny us our ability to use our communications, our intelligence, our verification, our early warning in space. After a year's work, I think everyone of importance in the intelligence community finally accepted that the intelligence was accurate and that the Soviets probably very soon would test, maybe on a manned space station, this technique and technology. I don't know whether they have, but in looking at the recent record-breaking Soviet experiment by the astronauts in the several weeks manning of their space station, I'm convinced from reading the Soviet releases on the experiments conducted that those Soviet astronauts did, in fact, test a laser generator, and that if they have succeeded, and they can find some way to aim these lasers, then the implications are incredible, because in a few minutes, at some distant point in time, the Soviets could destroy and neutralize every American and Western satellite in space.
So how is the US now preparing itself for the possibility of a war in space that must be dominated by a new space strategy? The military editor of Aviation Week and Space Technology.
I think in any space-based confrontation, the U.S. is going to be the loser. But I think that we have no recourse but to pursue that line because the Soviets are pursuing it. The Air Force in particular is rapidly moving in that direction. I think the appointment of Lieutenant General Tom Stafford, the astronaut, to head of Air Force Research and Development is a pretty good indication of where we might be going in that direction.
Tom Stafford, the former astronaut and now 3-star Air Force general.
I'm certain that my background in the space program for so many years, my experience in flying 4 flights in space and my development efforts in NASA was a big factor in my selection as Deputy Chief of Staff of the Air Force for Research and Development. From the background, I was involved in the development of the largest peacetime technical program in the history of mankind. It was a very successful program, so hope that I can apply my background experience both in developing the program that we had on Apollo, Gemini, Skylab, and the operations that I learned there into the Department of Defense.
So presumably you're a symbol of the growing awareness and importance of the military applications in space.
Yes, I think that's a very accurate statement.
What are you doing to increase the survivability of your own satellites and to reduce their vulnerability to both overt and covert attack?
We have an ongoing program now that has picked up a lot of emphasis as far as the survivability and hardening of our satellites, primarily in the electrical circuits. We're looking at the solar panels. Also, devices that can sense and give a warning that something is attacking the satellite. But the one thing is unique. You know, we have solar flares that occur every so often. And the physical phenomena when you have a solar flare is also, to protect against that, you also have a spin-off that you'd protect against, say, a medium energy laser or a nuclear weapon exploded at some distance.
And can one really, satellites are very vulnerable pieces of hardware, can one adequately protect them?
Well, you can develop a scenario where you know, near a nuclear weapon where nothing you could protect. But against a laser, it's possible and under certain conditions. So it's, this question is very broad as to give just a very simple answer to it.
Only a little way down the Californian-San Diego freeway from where the civilians build the satellites, the United States Air Force has its own Space and Missiles Systems Organization. It runs America's military space program, including the now #1 problem of satellite defense.
What ways are there for satellites to defend themselves?
Well, we generally put it into 2 categories, passive defense modes and active defense modes. In the passive area, we're talking about things like shielding, protective coatings, perhaps changing the satellite's appearance so that it can hide. In the active mode, we're thinking about things like maneuvering to get it out of the way of a threat,
Those are basically the two approaches that we're looking at.
Toughening or hardening the huge Navstar satellites is a priority. But how difficult is it to protect a satellite against laser beams and hunter killers?
From a projectile, it is extremely vulnerable. It can be knocked out. It's as fragile as an egg from a hard projectile. If a direct hit was made on this, it would cause damage. It could be enough damage to actually turn off the system or make it inoperable.
What precautions, then, can you take to harden a satellite like this?
As far as a projectile bombardment to the spacecraft, I don't think it's really feasible to protect the satellite. It would be more, in my thinking, to have a backup satellite, have many satellites in a system, and have more satellites available on a launch complex that you could replace if that became a problem.
So what are you saying? The cheapest way to harden a satellite is to sort of make it disposable?
That's right.
Most of the present-day military satellites, not just the communication satellites, are provided with an element of hardness. This provides some protection from the elements that they feel may be harmful to a satellite on orbit if a war situation developed. That capability varies as the years go by, as the different techniques are developed by the enemy or locally. The hardness of a given satellite changes. 10 years ago, when these satellites were originally designed, the hardness requirement was significantly different to what it would be from a brand new satellite. Continuous improvements are made as information becomes available, so they can be defended to a certain extent.
Presumably you can't defend against what the Soviets now have. Their anti-satellite weapon is something that explodes in the vicinity. There's no defense against that, is there?
Little or no defense. Moving away is about the only defense you get to that kind of situation.
And what can Discus do against attack by laser?
Discus has some capability to fend off attack by laser. The actual capabilities of laser attack are not totally understood, not totally known. So this is an area in which we are getting into the state of the art.
Yeah, in fact, I understand you work on advanced laser technology here, don't you?
TRW works on advanced laser technology.
So that presumably you're able to do a certain amount of experimentation
some internal
with
knowledge.
Your own lasers.
Yes, some internal knowledge is available.
And what conclusions have been reached about, or what broad conclusions have been reached about the extent to which lasers can damage these pieces of equipment?
Lasers are capable of damaging certain satellite components.
Badly?
Yes.
This is the much-heralded United States Space Shuttle. Built by NASA, America's civilian space agency, this revolutionary reusable space plane is already undergoing flight testing. It will eventually become the only way in which America gets into space. So by the mid-80s, America's entire military performance in space will depend solely on this vehicle. General Tom Stafford.
As you know, the space shuttle was designed from the onset, and I had a lot to do in some initial design of the space shuttle to greatly reduce the cost of putting a pound or a kilogram into orbit. And the same benefit you'll have for the civilian sector will also occur for the Department of Defense, i.e. to put a given satellite in orbit is going to cost us less money once the research and development cost is written off.
The space shuttle will be blasted into orbit from this gantry. In fact, it's one of two. The other one is under NASA's civilian control at Cape Canaveral in Florida, where the Apollo moon missions were launched. But this space launching pad is on a highly secure United States Air Force base, Vandenberg in California. Now, this is a military facility with strict security restrictions.
One major truth about the space shuttle is that the Department of Defense has already booked over 100 rides on it in the first few years of operation, starting in 1980. The more secret missions will be launched from this desolate Air Force launch site away from prying eyes, while many of the well-publicized civilian flights will go from Florida. In fact, the shuttle represents a giant step for military man into space. On launch, the shuttle will carry into space twice as much as any existing military rocket. The Russians have already complained that the space shuttle can be used as an anti-satellite weapon and that it represents an escalation of the arms race in space. It would certainly be naive to deny the shuttle, among its other roles, its potential as a superb satellite hunter-killer. One of the shuttle's major military missions will be to place spy and communications satellites into space. The satellite itself will be carried in the shuttle's main storage bay, and once on location in space, a giant arm will dump the satellite in orbit. But what goes out can also come in, and the Air Force acknowledges that it also plans to retrieve some of its own aging or broken satellites to bring them back to Earth. In the event of war in space, this could be a way of dealing with unarmed enemy satellites. At the end of its mission, the space shuttle will return to Earth and land just like an airplane. Although the Russians have no shuttle at the moment, spy satellite pictures have revealed a delta-winged vehicle that may be a prototype. It certainly seems most unlikely that the Russians will not challenge America's present dominance in this dramatic form of space travel.
Space is a frontier, an area, just as the seas are for the Navy. Space is for the Air Force particularly, but also the other services who are using communication satellites as well as all the other satellites that people talk about or imagine.
Now, the Soviet Union is already beginning to complain that the shuttle could be used as an anti-satellite device. Is there any truth in that at all?
I don't know that the shuttle provides any advantage over a satellite that we understand that the Russians already have.
But do you think that the shuttle could be used? Indeed, would it not have to be used by the Department of Defense to test Defense Department technology that would or might, in the end, be involved in active anti-satellite systems?
Oh, I think that opportunity presents itself very well. I think the shuttle will provide a test bed for many experiments, DOD, NASA sensors, different types of sensors, which in themselves can lead to applications such as you're discussing for the military. With the shuttle, because of its pricing policy and its size, you can build bigger satellites and you can add more weight to do what you want.
Right, and the hardening process, presumably, that gives you the ability to take heavier, hardened satellites, yes, hardened against directed energy weapons or whatever.
Yes.
Given that you have the ability to retrieve your own satellites, this arm comes out and can grab one of your own satellites, there's presumably nothing to prevent you quietly kidnapping or hijacking a Soviet satellite.
Well, I would agree with you except for one word. You said quietly. I think, yes, it probably could be maneuvered, but I doubt if it would be quiet, and I'm sure it would be recognized and seen by all the electronic devices that are tracking all these objects in space at this time.
So you could do it, but you don't think you could get away with it?
I think it would be difficult to get away with.
But presumably, in an emergency, there could be a military mission, yes, programmed to do that.
Yes, it's feasible.
Do you think that the Russians will want to treat your space shuttle as a possible anti-satellite device? And if so, would the United States make any concessions on its use?
I'd be quite sure that the talks would involve the possible use of any type of system as an anti-satellite device. But clearly, we would not be prepared to forfeit the entirely appropriate uses of the space shuttle.
Would you be prepared to make any concessions in the use of the space shuttle if the Soviets were to demand it?
Well, I'm not sure what you mean by concessions.
Well,
but if we were to agree not to interfere with the satellites of any other country, that would obviously apply to any type of system that we had. I don't regard that as a concession.
No, but you wouldn't, you wouldn't then agree not to use the space shuttle at all, or to modify its specifications.
That's correct.
Yes.
But the Helsinki talks can deal with only one aspect of the danger of a real war in space. There is another, and it is far more threatening. Since both Russia and America acquired the nuclear bomb, peace has been maintained by what's called the balance of terror. That means that both sides can destroy each other no matter who shoots first. So both sides have long been forced to acknowledge the sobering fact that an all-out global nuclear exchange would inevitably mean Armageddon. Intercontinental ballistic missiles must travel through space before delivering the lethal blow. And it's in space that new ways are now being found to destroy these ICBMs before they reach their targets. And that must undermine the whole balance of terror. In Part 2, the exotic new space weapons that herald the post-nuclear era and how they threaten all our assumptions about nuclear war.